Hello everyone and welcome to a bonus conversation. Today we'll be talking about Visual Studio Community Edition in the context of Python in particular. So jumping straight into it, what is it, right? So a fair question, always a fair question to ask, and it's basically a more robust sort of solution-oriented environment. We've talked in the past about Visual Studio Code. Visual Studio Code is more of a directory-oriented sort of solution. Visual Studio Community Edition is the free version of Visual Studio. The paid version has potentially more functionality, but the free version is not too bad. It does support most of the languages of interest. It does have things like autocomplete, IntelliSense, and so on. Includes things like being able to tie into various extensions and integrate with version control and so on. You can go download it. If you Google or go to visualstudio.com, you'll be able to navigate to the Community Edition, download it and install it. It will take a while because it is a fairly large program. Once you've done so, you'll land on a splash page. So this is kind of a Visual Studio thing. It lands you on a page that asks you what you want to do. You have the choices here of either opening something you've done in the past or creating something new. The various types of things you can create are available to you there on the right side of getting started. You can either clone a repository into the local environment. You can open up an existing project or solution, open up your file system and do things in sort of a file-based approach, or you can create a new project. For this example, we'll be creating a new project. Whenever you create the project, you're presented with a series of choices depending upon the various things that you selected to install during the configuration. In this case, I kept it pretty minimal. Most of the stuff here is around Python, a little bit of the typical sort of .NET stuff that one might want to do. But you do have choices here, and Python application is probably the place where you would start, especially in a data science sort of world. You give the project a name. So the way that things were structured is you have this concept of both a project and a solution. A solution is the container of potentially multiple projects. Sometimes you'll have one solution in one project, and so that's the typical pattern. You can give them different names or the same names. In this case, I'm giving them the same. You can also check that box at the bottom that says to put them in the same folder. If you don't check that, the solution will be at a higher level than the directory or than the project. The idea being you might have multiple projects nested underneath of a single solution. So once you've launched it, you write some code, and you'll see here that pandas wasn't known. You have the ability from inside of Visual Studio to manage your environment, so a Python environment. And in this case, I'm looking for pandas. And so I search for pandas, and it says, okay, well, what do you want to do? Install pandas is what I selected. And what that does here, it's going to prompt for administrative privileges. I grant them. And then we come back and it actually does the installation. At this point, it's going out and it's downloading pandas and going through the process of actually getting installed and configured. You do that approach for pretty much all of your libraries. It's a little different than some of the other environments we've used. And it also is important to understand this isn't a notebook environment. It is a single script intended to be a program that you write. So you can do debugging, and I'll show you that here in a minute. And the IntelliSense isn't smart enough to know that I've installed libraries. It's still showing that it's not installed. So here we can do a debug, which basically allows you to run the script and see the results of it. So in this case, there's no breakpoint set. I ran straight through it. Not all that terribly interesting. So now I'm going to set a couple breakpoints and then do a run again. You can see that we stop at the first breakpoint. Nothing's on the screen yet. I stepped through it, hitting something like F10, and at that point it wrote some stuff onto the screen that you can't see. We tab back over and you can see it. And what that allows you to do is step through the code a line at a time and see where things are, or what they're doing and what it's causing you grief with. Key kind of things to understand about this debugging environment: it's not as robust as some environments you might have worked in. For example, if you're used to writing .NET code, you can edit the code while you're debugging it and it takes effect. That doesn't happen in the case of Python and Visual Studio Code, or Visual Studio Community Edition. So it is a pretty rich environment. So shifting back over and actually to show you some more of it, I'll go ahead and exit out of the presentation and spend some time in Visual Studio. So at this point, I'll try to make that a little bigger so you can actually read it. The basic parts of Visual Studio, as you can see, this is a file on the left side that is in part of this solution. So you have a Solution Explorer. Solutions, as I mentioned before, this is the top level solution. Inside of the solution there's projects such as Deliverable 1. So you had a solution and then a given project. You have the ability here, if you were so inclined, to add a new project into this same folder. That's kind of the whole point of solutions, to act as containers. One of the nice things also to keep in mind is that it does do a certain amount of IntelliSense. So at the point that I do something like df dot, if it knows anything about what it is, or maybe pd dot, and it's poor examples, and that's why you should typically prepare ahead of time. So this is IntelliSense, and it's showing me the things. So I guess a better example would be, as I'm typing DA, you can see there that data is showing up, and so I can do auto completion by hitting the tab and then do whatever. Just an indication of part of what you get by using things like Visual Studio. So I'm going to set another breakpoint here, and that's what the red dots are, breakpoints, and then I'm going to go up here and say start, and that's going to kick off the debugger. There's a key sequence that'll do it as well. So at this point what it's doing is spawning an instance of Python 3.9 in this case, and it's went ahead and printed out, because I set the breakpoint when we're pulling in matplotlib. It's already printed out the two things above it, so the version and so on. But you can see we stopped on this line of execution. I'm going to head and hit F10, which is kind of the next step through. You can also do that by going up into here. You can step over or step into if you have functions that you're calling. So F10 is stepping over. F11 would step into something if we had something to step into. Import doesn't necessarily do anything interesting because we don't see anything change on our screen. This next line, and whenever I hit F, I'm going to hit F11, but it shouldn't go into anything because there's nothing to go to. You can see that it printed out matplotlib 342 as the version of matplotlib we're using. Go ahead and print out the version of NumPy we're using, in this case 1.2 or 1.20.3. Also, you do have the ability to notice down here at the bottom some local variables. It's telling me what the variables are that have been declared and used in this environment. You can also add watches, which is where you want to keep track of a specific variable over time, and even do things like set breakpoints. Whenever a variable becomes a certain value, you can stop execution. So the next thing, this should be a bit more interesting. We should see a bunch of values show up down here for X. So from the range of basically there's 100 values ranging from -10 to 10 and so on, and then we're going to go ahead and plot those using or convert that to a sign function. And so there's also now a series of Y variables that are associated with those X values based upon the sign. So we basically did some math here, right? The plot isn't going to be very interesting in this environment because there's nowhere for it to paint. It's not going to paint to a command prompt. This isn't a notebook, so pretty much you'd need to save that off to a file if you were going to do something with it that was more interesting. For now, let's see what happens on this next line. So now it's telling me that there's no module named IPython. So I'm going to save that name. I'm going to go ahead and stop my execution and go over here to Python environments and search for IPython. And then I'm going to say, okay, how about pip install IPython? Go ahead and let it do the elevated permissions. So it popped up and asked me if I wanted to let it do it because it needed administrative permissions to do that. And now it's going out and it's doing the installation of IPython. Installing the package, the various packages that it just downloaded. Also, a nice thing that is available to you inside of the environment, once it's finished, we'll be able to see it. So it successfully installed it. we can then, I believe, go up, go back, go ahead and close that. And you can actually go up here to the top and potentially select a different environment. So right now we're running in Python 3.9 because it's apparently relatively new. You also have the ability to, inside of your environment, do things like essentially view them all, and then also on a given one of them you can generate the list of things that are being used or imported inside of that environment. So you can generate a requirements.txt file. Requirements.txt is a way that you can basically say, if you're going to use my application, you need to have this stuff installed. And so basically what it went through was everything that's been installed, it created. We don't actually need most of those because we're not doing anything here with Flask. We're not doing anything with WebSockets or any of that stuff. So what you would, in this particular case, it's probably not a great use, but you can say that you want, I'm scanning to make sure I'm not deleting anything important. So we'll keep IPython and then get rid of these. We'll probably want to keep matplotlib, numpy, pandas, and so on. So whenever you've got a requirements file, then you can do a pip install essentially that will, you tell it this is the file that you need to look at to make sure that I have the components installed that are necessary. If it'll let me open a command prompt, and let's see if pip is here, and it is. I'm going to do a quick Google because I forget the exact syntax of pip install requirements text. I think it's a -r. So and I opened the command prompt in the wrong window, so we're going to go up here and open it here. And then it's pip install -r requirements. And this is kind of a standard way of doing things. So this is a way of basically saying, if you're going to run my program, you need these files or these libraries, these prerequisites. And so you essentially can create that file from inside of Visual Studio. So kind of a handy feature. And so that's kind of it in a nutshell. I just wanted to give you a brief overview of this as an alternative. Again, the key reasons that you might do this sort of thing is that it does, especially whenever you're in a certain environment. So in here I can say x.count, and it knows what I want to do. So I can do a print, and it knows kind of to some extent what I'm trying to accomplish. That's one of the reasons you might also, a lot of times you get some useful IntelliSense. So I'm hovering over the sys module, and it's telling me what that module does and gives me a bit of an indication of what methods are available to me using this module. And also you'll get a certain amount of intelligence around it. So it knows a good bit about sys. So I do sys dot, and here's all the things that I can do with that particular library. So just an indication of some of the value, and this is by no means exclusive to Visual Studio. Lots of environments offer this sort of functionality, but it is something that comes in quite handy. So the key takeaways here is that oftentimes IDEs are useful, valuable, can improve your productivity by helping you with things, a mixture of things like debugging, potentially also generation of things like your requirements file, and so on. So useful tools. You can also integrate these things with a version control. So you can potentially create a Git repository to store this stuff in, and log on to a particular repo and place it into that location, and in this case go ahead and publish it. So I'm going to go ahead and say create and publish, save my deliverable. The reason to do this is if you're collaborating, you certainly need repositories to store your information. You may also want to do it as a safety net in case something unforeseen occurs within your environment. So if your laptop was stolen, or something bad happened, you spilt soda on it or something. So again, all the various features, not totally unique to Visual Studio. Any IDE will likely have them. IDE stands for Integrated Development Environment. The idea is to make developers and data scientists more productive. So with that, I'll go ahead and wrap this up. If you have any questions about this or anything that deals with the course, do let me know. That's what I'm here for. Stay safe, and we'll speak again soon.